You got 1 point, you got it, ready? No, come on! How are you winning every time? Over the last several months, I've been building my own version of the classic toy Rock'em Sock'em robots. But because I like to overcomplicate and over-engineer everything I do, I decided to make mine life-size and controlled by pneumatic cylinders connected to an air compressor. This game requires 2 people to play, so I invited my friend Will over, but before we can have our fighting robot face-off, there are a few things that I need to finish first. Let me give you a quick rundown of my plan. In part 2 of this video series, I built a really simple control board for the red robot. All this board does is allow me to connect the 2 buttons as well as the 3 solenoids. I went ahead and I used one of these solderless prototype boards because it's quick and easy, but now I need to do the same thing for the blue robot. There are 6 solenoids in total, and each solenoid is going to need a MOSFET and a diode and several other passive components, and that's going to get really overwhelming for a prototype board like this. Not to mention, each robot is also going to get an inertial measurement unit. That's the accelerometer and gyroscope. And finally, each robot is also going to have LEDs in the eyes. So that's going to be a lot of work to build on a prototype board like this. So I think it's in my best interest to design a custom PCB. Because if I tried to build all of this on a prototype board, it just introduces the possibility for so many problems, whereas a PCB will be a lot more reliable, and should any problems come up, it'll be a lot easier to diagnose and troubleshoot those problems. This circuit board is pretty straightforward because it has a lot of repeating components. I designed one copy of my solenoid driver circuit, and then I just copy it 6 times. The same goes for the button inputs. I can design the low pass filter and then just make a copy of it 4 times. Once the boards arrive, I can use the stencil to apply solder paste, and then I'll just hand place each component and reflow them on my little hot plate. I finished assembling the circuit board, and here's what it looks like. The board is divided in half. All of the connectors on one side of the board will control the red bot, while all of the connectors on the other side of the board will control the blue robot. In the middle, I've got an Arduino Nano microcontroller, which reads all of the button inputs and then controls the solenoid outputs. I'm using a barrel jack to supply 12 volts to the solenoid valves. I also have a dedicated set of connectors for the LED eyes as well as the IMU sensor. This control board will sit between the 2 robots in the same place as the pneumatic control valves. Connecting all 6 solenoid valves will be simple because they're very close, but I don't want the arcade-style buttons that the players need to press to be in the center. And I'm trying to imagine myself playing this fighting robot game, and for me it sort of makes sense for each player to stand behind their robot as they're punching the other one. So what I did was I designed and printed this little button grip. So my plan is to wire in the arcade buttons and then attach the grip to the skeleton frame. And in order to do that, I need to remove the skeleton frames. The next thing I need to do is install the IMU. That's the inertial measurement unit, and that's going to be the little module that sits inside the chest and will detect when the robot is being punched. Each of the robots will have one of these IMUs in their chest, and that sensor data will be fed into the central microcontroller. That microcontroller will also be reading the button pushes, as well as sending out the LED information for the eyes in each of the robots. Here's the bar LEDs that I'm going to be using for the eyes. This is basically just 10 regular LEDs all in one package. All of the anodes are on one side and all of the cathodes are on the other. And to drive this, I'm going to be using a shift register. I actually need 2 of them because the shift registers that I have are only 8 bits and I have 10 LEDs, which is kind of silly to use an entire shift register for just 2 extra LEDs, but that's what I ended up doing. To make this a really clean install, I designed a little circuit board with the 2 shift registers and then a little connector that I will use for data and power. Unfortunately, the solder pads for the shift registers were just barely too wide to fit underneath the bar LED. So I had to get a little bit tricky. I actually placed it on the other side and I made them surface mount solder pads, but the problem is that this is a through hole component, so I'm gonna have to bend these leads over and make it a surface mount part. I'll admit that this is a really janky solution, but I think it's gonna work. The first thing I need to do is solder on the current limiting resistors for the LEDs, and then I'm gonna solder on the shift register and the connector, and finally I'll solder on the bar LED. At this point, I'm connecting the bar LED to the Arduino Nano, and I've written a little bit of test code to see if I can cycle through all the LEDs. As you notice, I've run into a little bit of a problem. While most of the LEDs light up just fine, it looks like the 7th and the 10th LED are not illuminating. So I've got to troubleshoot that. I'm really worried that I made a mistake on the circuit board design and that when I plugged it in, it burned out those LEDs. Hopefully that's not the problem. I can test each individual LED by applying 1.7 volts across each LED individually. And when I do that, it looks like both of those LEDs light up just fine, so I'm relieved that I didn't burn those out. But I still have the problem that they're not lighting up, so I'm going to start looking at my schematic a little bit closer, as well as my code. Okay, I did some digging, and it turns out that I didn't really make a mistake on the circuit board per se, but some of the LEDs used a really thin 5-volt trace that was around the edge of the board, and it turns out on that first board I built, I damaged that 5-volt trace, so it wasn't intact. Therefore, those LEDs weren't getting the 5 volts that they needed. Fortunately, I ordered enough parts to build more boards, so the solution was easy. I just needed to build another board. I also took the time and built 2 blue bar LEDs for the other robot. I've run the test code on all of these LEDs and everything seems to be working fine, so now it's time to install them onto the robots. So I need to move the robots to the front yard to do the end of the video, and I didn't have a great way to move them. So I put them on a piece of OSB, and I'm going to try to tug it along with the lawnmower, like on a little raft, but it's pretty top heavy, so I'm going to have my wife stabilize it. Hey, sorry to interrupt, editor Zach here. I just finished recording all of the footage that you're about to see, and unfortunately I had the shutter speed set wrong on my camera outside, so all of the footage is a little bit jittery and motion blurred. So I apologize for the bad quality.
You ready to rumble?
Let's get ready to rumble. Okay, ready?
All right, let's go.
Go.
Wait, come on.
Oh, there we go. Oh, it looks like you're down to like 5.
You're down to 1.
Oh, what? Are you serious? What? You already won? What the heck, Will?
Let's go!
Oh, I think this is rigged. I think that the red one is going to win every time. Okay, we got to switch now.
Okay, sorry, let's do it.
All right, let's switch. All right, round 2. So we've got Will with 1 win, Zach with 0. Do you want to do best 2 out of 3?
Yeah, let's do 2 out of 3.
All
right, ready?
Oh, something came out. This one's not working.
Oh, I see.
Okay, we just discovered that the red arm wasn't even attached. I right as we were setting this up, I found a little bolt on the table, and I was like, oh, that's odd. That's probably not a good sign. And I didn't think about it, and I just threw it in my pocket. And come to find out, that was for the right arm on the red robot. But Will won that round with 1 arm, so I don't even know what that means. Do we need to like tie 1 arm around your back? We need an extra handicap. I guess I should introduce who you are. Right?
Oh, sure.
So this is my friend Will. He's holding the camera, and he was super awesome and kind enough to come over and help me play this game, because it would look really weird if I was just playing by myself, right? It wouldn't be as fun to watch. So thank you, Will, for coming to help me out. I told him I'd take him out to lunch after this. So this is the solenoid that came loose. So I just need to attach the bolt in here, and it has a little nut that slides down in there. So it's a little difficult to reach. There we go.
There you go.
Got it.
Nice.
Okay.
Nicely done.
Should tighten that down. That's a little tricky to get in. Okay, let's test out, make sure all the other ones are tight before playing another game. Yeah, I can't believe you beat me with only 1 arm working. It's It's pretty embarrassing. Time for redemption.
I don't know, man. I'm feeling a clean sweep right here.
Are you? Oh, getting a little cocky, are we? Okay, I'm gonna hook up the air compressor, and these should all come back. Okay.
Nice.
Let's test out each one. Okay, so that one works. That one works. That one works, and this is the one that was broken. There we go.
That one, wow,
Okay.
that one's got
Ooh,
some
that
reach.
one's got a little punch.
Good right hook right there.
Right hook. I don't know any boxing terms. Okay.
All right, ready?
Yeah.
All right,
Round 2.
Let's go, Blue.
Okay. Oh, these have names. Did you know that?
No, what are
The
they?
original toy. So they have, it's Blue Bomber and Red Rocker.
Oh, okay. All right.
Yeah.
Nice.
3, 2, 1, fight.
Oh! How many? You got 3.
Oh, you're at 3. You're at 2.
Oh my God!
You're at 1. Come on, come on,
Are we
come on.
gonna?
Oh, no! No! You were at 1 point. You were at 1 point. I was like, okay, I gotta get one more hit in, and you're gone. If you hold all the buttons, both buttons down. Okay, it's reset.
All right.
All right, let's switch. Okay, well, I guess Will won 2 out of 3 already. So
All right.
that's really embarrassing. I gotta redeem myself here. Okay, I gotta channel my Rocky Balboa, right?
Yeah, right. Yeah.
Are you the Russian then?
I'm more Mike Tyson.
Oh, you're
vibe
Mike
right now.
Tyson? Okay.
But
You're taller than me. That's probably why you're winning. Like, I can't, I'm trying to see over there. Okay, all right. 3, 2, 1, fight!
go.
I'm like on my tiptoes over here. Oh, you're doing rapid fire here?
Oh, I was trying. I guess I'm trying to figure out what's the most efficient.
Oh, here we go. 3, 2. You got 1 point. You got it. Ready? No! Come on! How are you winning every time? How are you winning every time?
Did you rig it so that I would feel good
No,
about
I
myself or
promise
something?
you. Listen, I'm nice, but I'm not that nice. Well, I guess that's pretty definitive. You've won 3.
That was pretty close. though.
three in a row. Well, you are the definitive Rock'em Sock'em Robots champion.
Yeah, come get it.
I wish I had like a
belt to put
like
on
a big
you.
old giant belt or something to put on you, a trophy. I was tempted to put in, like, so there's the microcontroller is like the brains of it, and I have microcontrollers that can connect to the internet. And the way I've built this, like the buttons don't directly control the arms. Like the buttons are actually being read by the microcontroller. So theoretically, had I put in like an internet connected microcontroller, like I could play somebody across the internet. Like they could be pushing the buttons on their keyboard or something remotely and like playing the red robot, and I could be playing the blue robot. The problem though is like latency. Like between them pushing a button on their keyboard, like they'd have to be transmitted over the internet. I mean, like it would be probably a, maybe a half-second delay at the best. Whereas my buttons are being read like in real time, and like it wouldn't be a fair fight. So that's kind of one of the reasons, I decided against doing that. But the other option, which is more possible, is I could face these, they don't have to be facing each other, but like I could write a program and like have them be synchronized and like do a dance or like do, like a robot dance or something. Because like, they're all controlled from the brain. So there are options here. But anyway, if you have any ideas on how I could improve this or things you would have done differently, I'd love to hear about it down in the comments. That's it for this one. Thanks again, Will, for coming.
Of course,
and I'll see you next time. Having sponsors is great, and they make videos like this possible. But the thing that helps me most is when people like you go to patreon.com/bitesize and become a member. Sponsorships may come and go, but there's nothing that can replace long-term supporting members. So if that's something you're able to do, I would really appreciate it.